Today we're diving into the fascinating world of electrons. These tiny particles play a huge role in the universe, even though we can't see them with the naked eye. Electrons are fundamental to everything around us, from the devices we use daily to the very atoms that make up our bodies. In this video, we'll explore what electrons are, where they're found, and why they matter so much. Let's start our journey by understanding the basics of what an electron is and how it fits into the bigger picture of matter. Understand electrons, we first need to look at atoms. Atoms are the basic building blocks of matter. Each atom consists of a nucleus at its center made up of protons and neutrons with electrons orbiting around this nucleus. Think of the atom as a tiny solar system with the nucleus as the sun and electrons as the planets. This structure is what gives every material its unique properties. Electrons, though much smaller than protons or neutrons, are crucial for the atom's behavior and interactions. So what exactly is an electron? An electron is a subatomic particle with a negative electric charge. It's incredibly small, about 1,800 times lighter than a proton. Electrons are found in the space around the nucleus of an atom, and their movement and arrangement determine how atoms interact with each other. Without electrons, atoms wouldn't be able to form bonds, and matter as we know it wouldn't exist. Their negative charge also plays a key role in electricity and magnetism. Electron was discovered in 1897 by British physicist J.J. Thomson. Using experiments with cathode rays, Thomson showed that atoms contained even smaller particles, electrons. This discovery changed our understanding of the atom forever. Before this, atoms were thought to be indivisible. Thomson's work opened the door to modern physics and helped scientists realize that atoms have internal structure. The electron's discovery was a turning point in science, leading to many new technologies. One of the most important features of an electron is its negative electric charge. This charge is exactly equal in strength, but opposite in sign to the positive charge of a proton. Because of this, electrons and protons attract each other, helping to hold atoms together. The negative charge of electrons is also what allows them to move through wires and create electric currents, powering everything from your phone to your refrigerator. Electrons are found in the electron cloud, a region surrounding the nucleus of an atom. Unlike planets in a solar system, electrons don't follow fixed paths. Instead, they exist in regions where they're most likely to be found, called orbitals. These orbitals have different shapes and sizes depending on the energy of the electron. The arrangement of electrons in these orbitals determines how atoms interact and bond with each other. Electron cloud model is a way scientists describe where electrons are likely to be found around the nucleus. Instead of imagining electrons as tiny balls orbiting in perfect circles, the cloud model shows them as a fuzzy region. The denser the cloud, the higher the chance of finding an electron there. This model helps explain the unpredictable nature of electrons and why they don't have exact locations at any given time. Electrons occupy different energy levels or shells around the nucleus. The closer an electron is to the nucleus, the lower its energy. Electrons can move between these levels by absorbing or releasing energy, often in the form of light. This movement is the reason why we see colors in fireworks or neon signs. The arrangement of electrons in these energy levels is unique for each element and determines its chemical properties. Valence electrons are the electrons in the outermost energy level of an atom. These electrons are especially important because they determine how atoms bond with each other. When atoms interact, it's usually their valence electrons that are involved. For example, when sodium and chlorine combine to make table salt, it's their valence electrons that form the bond. The number of valence electrons affects an element's reactivity and the types of bonds it can form. Chemical bonds are formed when atoms share or transfer electrons. There are different types of bonds, like covalent bonds where electrons are shared, and ionic bonds where electrons are transferred from one atom to another. Electrons are at the heart of these interactions, making them essential for the formation of molecules and compounds. Without electrons, there would be no water, air, or even life as we know it. Electrons are responsible for electricity. When electrons move through a conductor like a metal wire, they create an electric current. This flow of electrons is what powers our homes, lights, and electronic devices. The study of how electrons move and interact in circuits is called electronics. Understanding electrons is key to developing new technologies and improving our daily lives. Electrons are everywhere in our daily lives. Every time you turn on a light, use your phone, or even breathe, electrons are at work. They're involved in chemical reactions in your body, the operation of electronic devices, and even the way plants make food through photosynthesis. Our modern world relies on our understanding of electrons and their behavior. Electrons play a key role in the creation of light. When electrons in an atom absorb energy, they can jump to a higher energy level. When they fall back down, they release that energy as light. This process is behind everything from the glow of neon signs to the light from stars. The color of the light depends on the amount of energy released by the electron. Electrons are also responsible for magnetism. When electrons move, they create a magnetic field. In materials like iron, the movement of electrons can align to produce a strong magnetic effect. This is why magnets can stick to your refrigerator or help compasses point north. Magnetism and electricity are closely linked, both relying on the behavior of electrons. Modern technology depends on our understanding of electrons. From computers and smartphones to medical equipment and renewable energy, electrons are at the core of how these devices work. By controlling the flow of electrons, engineers can design circuits, store information, and even create artificial intelligence. The future of technology will continue to be shaped by our knowledge of electrons. Chemistry, electrons determine how atoms bond and react. The arrangement of electrons in an atom's outer shell influences its chemical behavior. Elements with similar electron arrangements often have similar properties. Understanding electrons helps chemists predict reactions, create new materials, and develop medicines. The periodic table is organized based on electron configurations, showing just how important electrons are in chemistry. Physics explores the behavior of electrons in many ways. From studying electricity and magnetism to understanding quantum mechanics, electrons are at the heart of many physical phenomena. Their tiny size and unique properties make them both fascinating and challenging to study. Advances in physics often come from new discoveries about electrons and their interactions. Quantum mechanics is a branch of physics that deals with the strange behavior of very small particles like electrons. In the quantum world, electrons can act like both particles and waves. They can even be in more than one place at once. This bizarre behavior is what makes quantum computers possible and helps explain many mysteries of the universe. For every electron, there is a corresponding antimatter particle called a positron. Positrons have the same mass as electrons but carry a positive charge. When an electron and a positron meet, they annihilate each other, releasing energy. This process is important in medical imaging techniques like PET scans and helps scientists study the fundamental nature of matter. Electrons are found everywhere in the universe. They're present in stars, planets, and even in the vast emptiness of space. The movement and interaction of electrons help power stars and create the light we see from distant galaxies. Studying electrons helps astronomers understand the origins and evolution of the universe. Static electricity is caused by the movement of electrons from one object to another. When you rub a balloon on your hair, electrons transfer and create a charge. This is why your hair stands up or the balloon sticks to the wall. Static electricity is a simple but powerful example of how electrons affect our everyday experiences. Materials that allow electrons to move easily are called conductors. Metals like copper and silver are excellent conductors, which is why they're used in electrical wiring. The ability of a material to conduct electricity depends on how freely its electrons can move. Understanding conductors is essential for designing safe and efficient electrical systems. Insulators are materials that do not allow electrons to move freely. Rubber, glass, and plastic are common insulators. They're used to protect us from electric shocks and to keep electrical currents where they belong. Insulators are just as important as conductors in making sure our electrical devices work safely. Semiconductors are materials that can conduct electricity under certain conditions. Silicon is the most famous semiconductor and is used to make computer chips. By controlling the flow of electrons in semiconductors, engineers can create transistors, diodes, and other components that power modern electronics. Semiconductors are the backbone of the digital age. Batteries store energy by using chemical reactions that move electrons from one material to another. When you use a battery, electrons flow through a circuit, powering your devices. The design of batteries relies on controlling the movement of electrons efficiently and safely. Advances in battery technology are helping to create longer-lasting and more powerful devices. Solar panels generate electricity by using sunlight to excite electrons in a material, usually silicon. When sunlight hits the panel, it gives energy to electrons, causing them to move and create an electric current. This process, called the photovoltaic effect, is a clean and renewable way to produce electricity. Solar panels are helping to power homes and businesses around the world. LEDs, or light-emitting diodes, work by moving electrons through a semiconductor material. When electrons combine with special particles called holes, they release energy as light. LEDs are energy-efficient and long-lasting, making them popular for lighting homes, screens, and even traffic signals. The invention of LEDs is a great example of how understanding electrons leads to better technology. X-rays are produced when fast-moving electrons hit a metal target and suddenly slow down. The energy lost by the electrons is released as X-ray radiation. X-rays are used in medicine to look inside the body and in industry to inspect materials. The ability to control electrons is essential for creating and using X-rays safely. Lasers work by exciting electrons in atoms or molecules to higher energy levels. When these electrons return to their original state, they release energy as a focused beam of light. Lasers are used in everything from surgery and communication to entertainment and manufacturing. The precise control of electrons is what makes lasers possible. Superconductors are materials that can conduct electricity without resistance when cooled to very low temperatures. In superconductors, electrons move in pairs, allowing them to flow freely. This property is used in powerful magnets for MRI machines and in experiments to create faster computers. Superconductors are a frontier of research in physics and engineering. Electrons are vital in biological processes. In your body, electrons are transferred during cellular respiration, helping to produce the energy you need to live. Plants use electrons in photosynthesis to convert sunlight into food. Even your brain relies on the movement of electrons to send signals between nerve cells. Life itself depends on the behavior of electrons. Photosynthesis is the process plants use to turn sunlight into energy. Electrons play a key role in this process, moving through a series of proteins to help create sugar from carbon dioxide and water. Without electrons, plants couldn't make food and life on Earth would be impossible. This process shows how electrons connect the worlds of physics, chemistry, and biology. Cellular respiration is how your body turns food into energy. Electrons are transferred through a chain of proteins in your cells, releasing energy that powers everything you do. This process is similar to how a battery works, moving electrons to create usable energy. Understanding electrons helps us understand how our bodies function at the most basic level. Our brain and nerves communicate using electrical signals, which are created by the movement of electrons. When a nerve cell is activated, electrons move across its membrane, generating a tiny electric current. This is how you think, move, and feel. The study of these signals is called neurobiology, and it's helping scientists understand the brain and develop new treatments for diseases. Electrons can emit or absorb radiation when they change energy levels. This is the basis for many technologies, including X-rays, lasers, and even the colors we see in fireworks. Radiation from electrons is also used in medical treatments and scientific research. Understanding how electrons interact with radiation is crucial for both safety and innovation. Periodic table is organized based on the arrangement of electrons in atoms. Elements in the same column have similar electron configurations, which gives them similar chemical properties. The periodic table is a powerful tool for scientists, helping them predict how elements will react and what compounds they can form. Electrons are the key to understanding the structure of the periodic table. Ionization is the process of removing or adding electrons to an atom, creating ions. This process is important in chemistry, physics, and even in our atmosphere. Ionization helps explain phenomena like lightning, the glow of neon signs, and the behavior of gases in space. The ability of electrons to move between atoms is what makes ionization possible. Plasma is a state of matter where electrons are free from atoms, creating a soup of charged particles. Plasma is found in stars, lightning, and neon signs. The movement of free electrons in plasma gives it unique properties like conducting electricity and responding to magnetic fields. Plasma is often called the fourth state of matter. The beautiful lights of the aurora, seen near the north and south poles, are created by electrons from the sun colliding with gases in Earth's atmosphere. These collisions release energy as colorful light displays. The aurora is a stunning example of how electrons interact with our planet and create natural wonders. Lightning is a dramatic display of electrons moving between clouds and the ground. When the buildup of electric charge becomes too great, electrons rush through the air, creating a bright flash and a thunderous sound. Lightning shows the incredible power of electrons and the forces they can unleash in nature. Cosmic rays are high-energy particles from space, many of which are electrons. When these particles hit Earth's atmosphere, they create showers of secondary particles. Studying cosmic rays helps scientists learn about the universe's most energetic events like supernovas and black holes. Electrons are a key part of these cosmic mysteries. Particle accelerators are machines that speed up electrons and other particles to near the speed of light. By smashing these particles together, scientists can study the fundamental building blocks of matter. Discoveries made with particle accelerators have led to new medicines, materials, and a deeper understanding of the universe. Nanotechnology is the science of building things at the scale of atoms and molecules. Controlling electrons at this tiny scale allows scientists to create new materials and devices with amazing properties. Nanotechnology is leading to breakthroughs in medicine, electronics, and energy storage, all thanks to our understanding of electrons. Study of electrons is far from over. Scientists are constantly discovering new ways electrons behave and interact. These discoveries could lead to revolutionary technologies, from quantum computers to new forms of energy. The more we learn about electrons, the more possibilities we unlock for the future. Conclusion: electrons may be tiny, but their impact is enormous. They shape the world around us, power our technology, and are essential for life itself. From the smallest atoms to the largest galaxies, electrons are everywhere, connecting the universe in ways we're only beginning to understand. As science advances, our knowledge of electrons will continue to grow, opening up new frontiers and possibilities for generations to come.